Hey, it's great to have everybody here. We're going to do a session called State-of-the-Art Cloud Warehousing and featuring Rajat from Comcast as our esteemed customer.
Hello, everyone.
My name's Britt Johnston. I'm the Director of PM for Redshift, and really looking forward to talking to you about Redshift today and data warehousing in general. I'm sure you saw a lot of exciting announcements this morning, and I'll go over some of those so you can understand how those might apply to you a little bit. And Rajat, introduce yourself.
Sure. I'm Rajat Garg. I'm one of the senior principal at Comcast, particularly in the data engineering space. I'm here to talk about how Comcast utilizes Redshift as one of the environment for one of the key business function solutioning.
That's great. Thank you so much for
Thank
coming.
you, Brett.
So let's get started. First question for everybody. Hands in the audience of people who use Redshift today. So there's a good mix of folks here who are current users and want to learn. So we'll dive into some details with that. At today's session, I want you to get a little more detail, more depth in some of the things you heard about the announcements today. But I also want to do that in the overall context of data warehousing, so you understand how that fits within the AWS suite of services. Make sure that you can understand how to the details of that relative to your own organization, and then help you plan on what your next steps might be. So I'm hoping you can walk out of here with something that you can go do and take action on as part of that. When I think about what we need to talk about overall, there's three things that pop up that I hear over and over again from many customers. The first is really around the explosion of data. And I know it's interesting that it seems like every year we talk about the explosion of data, but you know, a few years ago it was a theoretical thing. There's this coming explosion of data. Now it's actually here and we're having to deal with it. And it's a bit shocking sometimes how much can show up in your, in storage. And so organizations are having to really examine their strategy for how to manage the scale of what's going to be there. What's important, what's not. In effect, what I see is often different data has different value to your organization. And so one of the things I want to give you are some tools on how to think about that relative to our offerings. The next one is there really is an expansion in the number of types of individuals that need to get at that data. What I see is many more analysts are appearing. When there's a lot more data, there's a lot more to look at, there's a lot more questions to ask, and so we're seeing a real growth in the number of individuals that want to understand or want to use that data. And there's also new types of individuals in, for example, the data science space that want to take that data and use it for another purpose, to train a model. To be able to create some sort of automation. And so those are putting pressure on the system. And that third point is really the demand that we see for access to that data. It's really rising. So in a lot of cases, we're seeing the number of individuals that need to get access or actively touch systems rising much faster than the organization expected. And that can really push on both the infrastructure that's there and also challenge the organization from a budget perspective. And we're trying to deal with all of these things here in AWS. First of all, I want to make it really clear there are a broad set of services around analytics overall that you can look at. From an AWS perspective, as we look out over the data lake, there are data warehousing offerings, big data processing, interactive query, and operational analytics types problems that we see people struggling with. And there are specific solutions for all of those kinds of areas. But what we're seeing also is that those are blending together. In our particular case, we're going to zero in on the first column there, our data warehousing particular topic, and I want to drill on that some more. But keep in mind it's in the context of a family of services that can all work together to help you solve your problems. Now let's look at some trends that I see. One of them is acceleration on migrations. A lot of organizations saw their data warehouse as a system that would be moving late to the cloud. And so it was maintained in its existing state, potentially for an extended period of time. And often that means there's pressure to move that, to migrate that more quickly than maybe was expected. And that pressure is something that's real. We try to make sure we provide tooling to help make that easier. But that migration to the cloud is accelerating. And whether it's from a device like a Netezza or from an Oracle system or a Teradata system, those are the common places we see people moving systems on premises into their public cloud. We talked about the exponential growth of data or explosion of data. The other piece of that is very specifically event data is one of the kinds of data that's really growing fast. And whether that's simple log information coming in or whether it's telemetry coming from devices, those events are really increasing at rate. And often the precision of them is rising as well. So where you may in the past had let's say entry-exit data for people leaving a building, those systems are being upgraded now to where they monitor every single activity for that. So the amount of data being collected is exploding on that level as well. And the last one is a real need to get more insight from the data. With all those additional people working, making sure that they can be effective, have the right tools to help them operate is really important. Now, along with all of the offerings we have, one of the things that really, I think, sets us apart is that we embrace the data lake. We think it's a very important part of your specific solution and something that you should really focus on from a strategy perspective. If you're dealing in that world of exploding amount of data, you've got to decide the value of it. You have to decide what data is going to get loaded into your operational systems, what's going to make its way into your warehouses, which should be archived or maintained in some way in your data lake, and so that contrast, if you will, between what's in your data lake and what's in your warehouse is something that people struggle with. We really think that shouldn't be something that you should have to struggle with. And instead, we kind of think of a different way to think about that, and that is from a Redshift perspective, instead of a warehouse, some of our customers actually tell us they call it their lake house, which is got a nice appeal to it. And the notion is that you can have data either in your warehouse or in your data lake, and you can query any of it. And we'll get into some details about that. But that really unlocks that asset so that you don't have to ingest data into a system in order to be able to look at it. You can look at it in place. You can maintain it in an open format. It really can simplify how you can operate. I want to quickly run through some of the Redshift benefits that we have talked about. First, we've mentioned data lake and how it's integrated with many services. Best performance is something that you should understand we spend a lot of time on as well. Our measurements show that Redshift is going to be 3 times faster than anything else you can find for analytics. And we run those benchmarks on a continuous basis. In fact, we just got an update over the weekend, and the numbers we've gotten for the conference actually are getting better. And so we're literally improving on the day level in terms of how the performance is. And so that's exciting to see. Lowest cost is also fundamental. We want to make sure that you pay the minimum you have to be effective, and we're always trying to drive down costs in terms of our solutions. We want to make sure that it's easy to use. So making sure fully managed service is something that you can have. With Redshift, you don't have to maintain software and worry about patching systems. We take care of that for you. It's also very scalable on every dimension, whether it's the amount of data, you can handle up to 8 petabytes of data in a single warehouse, or whether it's a number of users. We'll talk a little bit more about that. Those are something that we want to make sure that you feel comfortable with. And lastly, the foundation of all of it is really around security, making sure that we provide appropriate security platform, encrypt your data, make sure that at rest it's safe, make sure in transit it's safe. And so spend a lot of time on the appropriate certifications to make sure that you can have that comfort. Redshift is used by tens of thousands of customers. And so is something that we're excited to be able to keep growing and expanding. You know, we launched this product in 2012, and it was the very first cloud data warehouse. We cracked the code in figuring out how to operate at scale in the cloud with that much data. It really disrupted the whole space and lowered the price barrier for warehousing permanently. There's a lot of people involved in this, though. With all this data, there's a lot of activity there. There's a lot of competitors, and know that Redshift remains the fastest, the most cost-effective solution out there, and we're committed to keeping that. We're working at a really fast pace. In just a short time, 200 major features are going out, and they're going out all the time. In the last couple of weeks, there's been almost a dozen features launched. And from that, if we categorize the big ones from 2019, we can see this list here. In performance and scalability, ease of use, and data lake integration, we've got a stream of those that are coming out. I'll touch on a few of these as we go through. The first one I want to mention is our new console. One of the things that we did recently is ship a brand new console. It's all out there for you to be able to use. Very beautiful from a look and feel perspective, but it also is optimized to let you manage, for very large organizations, let you manage multiple warehouses where you may have different purposes for them. So things like lists of clusters and things like that. And in some cases, you know, you might have a production system, but multiple dev and test kind of environments. So being able to manage those effectively is something it's optimized for. Making sure that we reduce the time it takes for you to diagnose your issues is something that's really important. We know that if there is some unknown in terms of performance or something like that, you want to be able to investigate that very quickly. And so making sure that that's as easy as possible. I mentioned new classes of users. We have a lot more analysts that are out there, and they don't want to have to use the console. So one of the things we're in the middle of making available is the query editor being available on its own URL, so that analysts can go and use the query editor without having to get access to the console. And so that's something that we want to make as part of that as well. And make sure that people have access to some great tools. You know, a good way to aggregate a lot of what we've done is to look at how it's affecting out-of-the-box performance. If you just take a Redshift cluster, start it up, load data in, and run a query, and you don't pay any attention to optimizing anything, we've really improved the performance of that alone. And with some really smart improvements around encodings, fancy filtering, fancy optimizer with a planner that's much improved, modern statistics using things like HLL as part of that, and making sure that we can take advantage of our caches in there. The net of that is, even just over a short while since June, we've seen over 2.3 x speed up in query performance. So there's a constant rolling improvements that you get with Redshift that we're excited to be able to share with you. I want to drill into a couple areas where we're spending time on improving, and one is really interesting. You know, something as fundamental as an encoding wouldn't seem like that exciting a topic. In fact, isn't this already figured out? It seems like a solved problem. Well, it turns out we've done some work to create a new encoding we call AZ64, and it not only reduces the amount of storage in almost every case, but it also speeds up performance. So it's more space efficient and more compute efficient at the same time. And so it actually shrinks the size of your overall data set and allows us to process it faster. It's amazing to see that kind of innovation that we can bring you. I want to switch gears a little bit and talk about how people are solving the data warehousing problem. You know, the traditional approach was a monolithic system, and when we cracked the code in the cloud, we really used a shared nothing approach to that, and that's on the first picture there, where the compute nodes and the storage are tightly bound. And what that meant was you had to add compute to add storage. And so that approach still provides the absolute best performance because the distance between the data and the compute is the very smallest it can be. What's evolved as the cloud has improved is this concept of shared storage, where you have a single place you have storage and then you use your network to push the storage back and forth to the compute. Now, that has a lot of benefits in terms of ease of use, but it also means that you're going to introduce the network as the bottleneck by definition in there. And Andy Jassy talked about that today a little bit in the keynote to do that. That bottleneck is real. The network speed is slower than the processor and the disk, and so that's going to end up essentially as a governor on how fast your system can operate. We really think that there's a better way to solve that, and it leads to what we call disaggregated compute, where we take the data and we actually move the compute to the data. And that approach really is revolutionary in terms of how that operates. And so we're on a journey to build that out, and we've made the first announcements on that path at this event. The first of those is our new RA3 Amazon Redshift compute node. We're excited about this. It's quite a powerful node. It can handle significant workloads, but what's really exciting is for those of you who are currently using a DS2 cluster, what you'll find is the RA series is about twice as fast and can handle twice as much storage for the same cost. And so literally, you can make the decision whether you want to reduce your costs or increase your performance in terms of how you want to operate your system. We're really excited about that change, and that's really just the first step. The second step is what we call AQUA. This is a hardware accelerated processing layer that we're created. It is how we're going to implement disaggregated compute. It'll let us push down complex query operators into effectively closer to the data so that we can speed up things. And we expect this is going to have a 10x improvement in performance. Really revolutionary as part of that. Now, I want to jump in on a few more topics to make sure you're aware of them. Increasingly important, I talked about there's all these different data sources. One of the things we announced today is the availability of federated query. Federated query in preview is a really important feature. It lets you, from Redshift, take your query, reach out not only into Redshift, not only into your data lake, but also into your operational stores, so that data that's in RDS and Aurora PostgreSQL, you can directly query that from Redshift as part of that. It really makes it more flexible to operate your systems. What it means is you can change a little bit the frequency of ingestion, because you can build apps now that can reach into those operational systems for the very latest data, and the pressure is not on that as high to ingest that data into your warehouse as fast as it. Or you might decide some of that data doesn't need to be ingested because you just go to the operational store to get it when you need it. So that really is an improvement. Next one I want to talk about is materialized views. This is really important. Materialized views allow you to define a view, which we're all familiar with, but actually creates the view and stores it in the system. What that means is if you've got a 10, 12-way join with all sorts of complicated operators in it, we can pre-compute that and maintain that inside Redshift, so that when you have a query that uses that materialized view, it can get the answer immediately. The performance speed up from this can be astronomical. It really can be orders of magnitude faster from this. And so we're really excited to have that out there. This is going to be something we're going to be building on. So materialized views, you'll see improvements going forward in that space. Now, new data types. How many people out there have a need for spatial data, geometry? A bunch of hands go up. And not everybody quite understands that. You know, a lot of people aren't used to having that data type available to them in their stores. But we've implemented a geometry type and done it in a way that's very performant for building geo type or spatial type queries. We're excited about that, and to be able to do that. That's something that we launched recently. Another area where there's a lot of emphasis is removing the needed expertise from the administrator and letting them focus not on tasks that can be automated, but on tasks that are more suitable for their experience and skills. What this means is things like when to run analyze, when to sort your tables, what keys to pick of various kinds, whether distribution or data keys. Those decisions can be made by an AI. We've created machine learning models that understand, they can look at the data, understand what the best possible example of these, and then recommend that for you. What you'll see over time is these will become the default, so that we will choose these for you. Today we're in the process of rolling some of that out, but we want to get to the point where you don't need to worry about any of those maintenance operations on your data. All those are managed by the system automatically. One of those I want to drill into is automatic table sort. Really interesting problem. You know, typically when you need to resort your data, it would be a monolithic operation, right? You'd go and resort all of the data, and it's fairly complicated. Well, the approach that we're able to take with Redshift is to chop that down into pieces, and in fact prioritize the ones that are need the most work. So in this picture here, you can see that our last slice of data is the one that's the most used, and so we'll make sure to prioritize sorting that first. We'll get the most benefit out of that, and then we can clean up the rest of it later. But making sure that we're really smart about that, which means the amount of resources being used for those maintenance operations drops way down in the system, and we shift them towards times when the loads are less. I want to mention scaling. This is an exciting point as well. Concurrency scaling is a technique that we use that can allow you to expand rapidly the amount of processing that you can do within your Redshift system. And what it does is it creates additional clusters within seconds so that you can start to operate on them. And so the net of that is as you reach a point where either additional users or the number of queries executing concurrently rises beyond the ability of the system to handle it, it can dynamically expand to handle that and then contract back down once that peak is done. Concurrency scaling alone in this year, we've increased the performance of that by 35 times. So we've really made that, tuned that so that it not only starts faster, but is more effective in terms of how it operates. This is interesting because it's a feature that you turn on, and those additional clusters are billed for the processing that they do. But you actually get credits for those as you operate your clusters. And so one of the things that many of our customers do is they turn this feature on, take advantage of those credits. And in fact, of all the operating that we do, 97% of clusters out there are able to simply use those free credits and get all their burst capability that they need out of that. So that's a really effective tool that you can use. Last thing I want to mention is around complex workloads. You know, I mentioned that there's all these different kinds of users hitting the system. Some are important, some are less important. And being able to prioritize them intelligently is vital. And so we have what we called workload management, and the ability to find query priorities within there. What you can do is go in and create groups of users and give them names. And in our example here, we have an ETL as a group, in this case, probably machines. We have the BI and analytics group, and then we have our data science group. And we can see different priorities. We can have the ETL be high, make sure it always occurs as fast as possible, have our analytics be in the normal state, and then our data scientists can be a little lower because they're generating their data to train models, and we don't want them to interrupt the business. So you can code that kind of, or encode that kind of rule into your system. So hopefully you've gotten a sense of Redshift, all of its capabilities, understand some of the trade-offs that we make in terms of data lake, ingesting data into a warehouse, but then realize now that we make it really easy for you to make those decisions and then evolve over time as the value of your data evolves. And with that, it's really a pleasure to have Rajat come up on stage. He's from Comcast and really wants to share with you an example of how he is solving this problem. So with that,
Thank you.
Rajat, thank you.
Great, appreciate that. Hello, everyone. Just for a quick introduction, back again. Myself, Rajat Garg. I'm the senior principal at Comcast and particularly represent the data experience team. We're the team that primarily focus on revolutionizing the experience and handling of the data for the enterprise, at least to the majority of the part. In our use case, the thing that I'm going to be talking about, how do we solution from a legacy system instead of changing the approach of being defensive from migration by going offensive to really re-architecting and rebuilding in the right way. Okay. Like I said, I'm going to be talking about one of the key data systems that we had traditionally in the Comcast, serving one of the key business functionary, and how we transform from on-premise, moving over to the cloud successfully by utilizing various AWS components like S3, ORC, Redshift, Spectrum, Athena, and Lambda. It also uncovers, for many of you traditional ETL developers, what could be the complex ETL scenarios and how do we approach it, how do we solution it, going from traditional data warehousing into AWS, what components did we utilize for our ELTs, and also what was unique in our solution in terms of our Spectrum approach that provided a force push down to a lot of query federation. Okay. Before I go to that, I really wanted to talk about what are the key considerations when you're going to such kind of a journey. When you're starting something from moving what you already have, a kind of a way of working, what do you want to move next? What are the considerations that you want to keep? People say, let's move to Redshift, but why? One of the key challenge for me was infrastructure. We are supporting one of the key business function across the enterprise, and infrastructure was really one big challenge. It was a really powerful system, but being an on-premise, I think that's really very straightforward that why do we need a cloud in that? What can we gain by moving from on-prem to a cloud? Other consideration is scalability. Everybody knows that. How much time it takes to procure if you have to go and expand your infrastructure. How to occupy and scale it more. With moving to AWS, one of the key considerations was easy expansion or scalability as our data explode and expand more. Performance, of course. When you're dealing with a traditional user base who are working on the system for 15, 17 years, one thing you cannot argue or win with the argument is performance. You have to give them the same performance that they're currently used to. Redundancy. How many of you might have heard already CPP? And with that legal term in play, how many of you think redundancy of a data is now a nuisance and going to be increased nuisance going forward. Storage. How do you capitalize maximum on your storage from you going traditional to AWS? And of course, many of you belonging to different corporates have realized one of the problem is different data silos. Like you would have a multiple data systems across within the same company, solving part of the data functions across within the same business organizations. How do you get rid of that? Before I do that, I really wanted to showcase on like what was a legacy system, one of the big powerful legacy systems we had that of course there are many more, but this was one where I started a journey of a migration or a re-architecture. It was a really powerful Accelerator rack, X32 server, actually the 7 servers we had, huge powerful SAS disks, infinity bandwidth, and really 64 cores, 10 gig connectivity to the data center, quite powerful, right? And 11.2 terabytes of flash drive, really for fast processing. Huge powerful system. That means the challenge that we had in our migration and re-architecture primarily was around performance, apart from other consideration, because we had to give a convincing solutioning to the user that they are not losing the performance that they are currently used to. The system itself was supporting 50 plus unique data sources, 35 plus external data vendor exchanges. Really, if you talk about dimension and really the subject areas, I would call it like we ended up having around 450 plus, somewhere close to data constructs, heavy power users, 3,000 plus reports, multi-division support, the way Comcast is spread out across divisions. And it was right now only delivering single channel integration, not really transferring the data across all the channels that we have. And also was only supporting single business entities, but not across the business entities within the same, plus the line of businesses. Current network topology. This is the solution of the network topology that we deployed for the Redshift. We have 3 VPCs, dev, prod, and of course reporting one. All of the things that you see beneath that, there is the S3 data lake. A few minutes back, Britt has talked about one of the data lake solutioning. This was really one very key component for us. How do we want to make the data through the data lake available for our user for the business function, but at the same time for analytics for their compute functions, but at the same time not to replicating the data. The data lake concept on the top, Redshift sitting on it, that's a key solutioning aspect that we at least try upon. Okay. This is a fair representation of like quite large number of data sources we have, and what was our ETL strategy that we use. Traditionally, we do have a big data system, a Hadoop system, really powerful one, where we store and stage all of our data, perform a lot of our ingest operations. Many of that we use direct connect to get it into S3 to build as a part of our data lake. From there on, the major part of our journey of the ETL start, many of us are used to writing BTICs, many of us are used to using Informatica, many of us are used to writing some other traditional data warehousing tools for most of our ETL operations. But when we were moving to AWS, this was one of the key challenges that we faced and how we approached it. There was, I'll say honestly, there is no easy way out. You have to try a lot till you find out really the best one that works for you, because there is nothing like Informatica that does everything for you when you're moving from traditional to Redshift. We utilize Hive and Spark, we utilize Glue, we utilize Spectrum itself, we utilize Athena. One of the key part is the main point is the last is all the data sets that we use, most of them are stored as external data sets and accessed via Redshift. Okay. What did we gain by going with that data lake approach? Why was that data lake approach really successful for us? I mean, before saying it, I would probably just show some numbers. What was our execution times? And this is the worst case scenarios that we have tried and executed to do the benchmarking. We have a traditional data warehousing in Teradata. We compare the same query in again the legacy system, high power Exadata, and again using the data lake approach against Redshift, using via Spectrum. Clearly the results are itself speaking a lot that Redshift definitely stands out in many of those scenarios in terms of performance. At least with a bare minimum, we could see that performance was 10 to 15% better than what our traditional user were used for that business function, 25% against our enterprise data warehouse in itself. Of course, that does go with a key consideration. It's not a lift and shift. It's not a migration. It's really a re-architecture that we need to focus on. Data storage, compressed. One of the key point, but also mentioned about the compression, like they're coming with AZ64, I believe. In our scenario, ORC and Parquet really was a key. How we stored our data in the data lake and how we manage our data in the data lake and put the Redshift on the top of it. I think that really helped us a lot in achieving some of those benchmarks. Appropriate data bucketing, appropriate data partitioning, and really the partitioning size and effective queue slots. All of those things does matter. There is not a magic bullet that a lift and shift. We'll have to go through that pain process. We'll have to really find out the right balance and approach, how you manage your data and how you store your data. Evolution, of course, this is the current state. We still have the evolution defined to help improve some of our performances. Like I mentioned initially, most of my data are stored as external in Parquet or ORC with these partitioning. As my evolution journey is, I'm going to be doing hot and cold data using local cache. That's our next step of the agenda. Transient cluster, concurrency scaling, and of course, Spectrum caching, which is, I think it's one of the new features which Spectrum has really recently announced for template-based caching. Scalability. How did we manage to scale multiple Redshift clusters through PGBouncer? That definitely going to throw up many of you. Oh, we're talking about Redshift. How is PGBouncer fits in here? We all have realized that there is always going to be a bottleneck in terms of our compute when our data get expand. How do we manage scalability without copying the data across multiple clusters? I think that's going to be the key of how do we increase our concurrency limit, how do we maintain still the same seamless data lake structure, plus how do we expand our Redshift. The thing that we utilized was PGBouncer. What it really does is it's kind of provide us a proxy mechanism that can help us manage multiple Redshift cluster, but really utilizing it as a decoy where we don't really have to copy the data locally onto any of the Redshift cluster or into multiple copies. We can still maintain the single copy of the data within our data lake and access across multiple Redshift cluster managed through single point of entry provided by PGBouncer. If you see in our implementation of this open source, what we have to do is we have to implement a load balancing mechanism in our proxy where we have a PGBouncer multiple load balance proxies, and we were capturing any of the application requests or any of the user queries that was get thrown at Redshift. It goes first passed through PGBouncer, and you see a small piece of a code. It's an example, like some of the piece of code we actually inject behind the scenes in the user query without even user knowing by rewriting dynamically user queries. What it does is it helps us push down the queries in a really high performance way to utilize Spectrum engine and alleviates our concern on utilizing local. It's not that you cannot, of course, if you have a hot and cold data or hot data, you might want to consider still utilizing local, but majority if you're really dealing with a high data size, Spectrum really is one of the key performance engine that worked for us. Data redundancy. If you see in our current architecture, we have a data lake architecture. We are utilizing application databases like Redshift. We are utilizing Athena for user data exploration. We are utilizing Presto for query federations. We are utilizing Databricks for analytics. But none of them had made us really make multiple copies of data. We can still live with the same single data existing into data lake without making multiple copies, and still can run by multiple compute systems. Okay. Architecture now. I know it does not present a really glory picture, but I definitely wanted to focus on this one a little bit more. There's a prime reason why. The journey is not going to be easy. When you're moving from your traditional system to cloud, and particularly your data warehousing, you have to be prepared to some kind of a complexity in the beginning. Of course, with the back in mind that, okay, what's going to be the evolution in my future, how I'm going to simplify it. We have on the left-hand side, you see like a huge list of data sources across. We have a big data Hadoop environment where we have all the ingests. We have a direct connect, which we utilize through Blue Proxy and moving to our S3 data lake. That's where our journey starts to ETL, which is again a multiple component based on tests and experiences that we gain to understand what kind of a load, what kind of ETL work for what tools in AWS, particularly for Spectrum. And then, of course, our presentation layer is Redshift, where most of our application user comes and query the data. We also have the same data lake exposed to multiple other use cases like Presto, as I was explaining, for Tableau reporting, for various of our vendor data exchange, for data sharing across the company. How do we, and of course, the multiple Redshift layer, if you're going to see, is still going to be managed by PGBouncer, which is kind of a load balancing proxy mechanism that help us not to copy the data, but still be able to get multiple compute engine as you scale. This is architecture now, and this is our future 2020 roadmap. The way we are going to simplify it, now we have successfully migrated to Redshift all the legacy systems, and we have been able to reduce those silos. How do we simplify from that complex architecture and minimize our footprints and make it a simple, seamless flow? We have divided our data ingest into 3 portions: real-time, database level, and file-based systems. Everything, of course, still has to go through our data lake, but this time it's going to be entirely S3. Databricks for all our ETL operations. That's going to be resulting in our curated data set that eventually going to be utilized for all our presentation layers, and of course also going to be made available to every other team or every other use case that needs to use the data without making the copy of the data through the data lake. So if you see that the curated data set, the first portion of that is there is a Redshift layer, again managed through PGBouncer, a simplified layer. On the top, if there is a separate compute through Presto or Athena, if somebody wants to do data exploration, somebody wants to do analytics, somebody wants to do more computation without copying the data. Plus, we are also focusing in this new Evolve architecture on some of the real-time, or I would also say high concurrency, low latency use cases, where we have a very near real-time executions on a trigger base. Benefits. This is our 2019 results after our successful implementations. System operation cost, I mean, the previous one, which we have a traditional warehousing, I'm not going to be able to say how much money we were spending, but eventually we were able to save $3 million OpEx. If many of you are technology leaders, you know the need of OpEx saving within an organization, how big of a deal it becomes. Infrastructure cost, this is our cost reduced by 30%, and that's when we are fully right now running on demand. The reason of us running first year in on demand was we wanted to collect enough stats to make sure we are using the right instance before we go reserved. That means this cost is really going to be going down much more somewhere in 2020. Easily scalable, reduced data redundancy, already ingested. We have expanded the same system to 1 business unit to 3 business unit, 1 channel to 4 channel. At the end, we do gonna have a target in mind to do omni-channel and multiple business unit without making multiple copies of the data, the single layer of the data that was there in traditional data warehouse. Future evolution, like I said, local caching, hot and cold data, spectrum caching from template-based to object-based, more real-time and event-based ingestions, increased concurrency, and of course, spectrum auto-scaling. Okay, with that, I'll hand it over back to Brett here, and we'll open for Q&A.
So really, really interesting, you know, how you've solved that and really took advantage of the fact that Redshift can directly go after your data lake. What you saw there was an example of an architecture where creating data in open formats and then accessing that data using Redshift was a first-class approach to that. So what have we covered here? Hopefully you've all learned a little bit more about what was announced at the keynote as we went into a little bit more detail on that. You know, the innovations there and the scale of that is something hopefully you have a sense of now. All the work that we've been doing over the last year as part of that. Some of how that rolls up into performance improvements that you can personally take advantage of. Hopefully that helped you understand how you might use this technology to build your own solutions, and you saw an example of one approach to doing that. You know, really how you want to put the pieces together is going to be heavily influenced by your particular organization and how you use data, and hopefully you can think about what your next steps might be. One of the things I'd encourage you to do is understand your data sizes, look at the Redshift cluster offerings and understand what might make sense for you. We have specific guidance around that. There's wizards essentially built into the console to help you very quickly start out and get experience on that. So going and experimenting with Redshift is something I'd encourage you to do as a next step. With that, we can take some questions. I'll put on the related sessions here so you can look at that. If people would like to ask questions, if you could come up, some brave soul could come up to the microphone and get us started. That's how we kind of need to do that to capture that. Thank you.